Hello everyone, in this video we will do Leetcode number 63, which is unique paths 2. This is a follow-up of number 62, which I also have a video on. So if you haven't watched the number 62, which is unique paths 1 or just unique paths, then please watch that one first, because in this video we'll be building on that uh, code. So in the previous problem, we just had to find the number of ways to get from the start to the end, and we did that using recursion and memoization. In this video, we have the grid, but then there are obstacles on the grid. So basically, if there's an obstacle, for example, here, he can't go right and then go here because it's an obstacle. So this won't count as a path. And so let's start by the code that we had in the previous video. So this code is what we produced previously, that just calculates the number of ways from start to end without any obstacles, right? So now to implement this one, which is unique path with obstacles, so I'm just going to copy this function in here. So now this unique paths helper still applies because we still need to find the total number of paths recursively, but we also now need to take into account the obstacles. So I'm going to add a parameter here for the obstacle grid, and then basically after we check that it's like the x is valid, we immediately check if it's an obstacle, right? So if um, and it says obstacles are marked by 1 on this obstacle grid. So basically it's the obstacle grid is the whole grid, like a 2D array, wherein 1 represents an obstacle and 0 represents a free square. We still have to find a way from the top left to the bottom right corner. So um, yeah, so now we can check if the obstacle grid at start y, we do y first because first this is the first row is the 0th array, and then this is 0, 1, 0, 2, 0, 3. It's like a 2D array. So the first row is the 0th array, the first array, and the second array. So it's the y value that determines which row we're on, and then the x value determines which column we're on. So start y, start x. This is similar to this um, 2D array as well. So the same format. So then if obstacle grid at start y, start x is equal to 1, then that means there are 0 ways for you to get to the destination, right? Because there's an obstacle there. So if you go there, there's 0 ways that you can get to the destination. And then we have to move this check for if you are at the destination after here, because there could be an obstacle at the very end. So if we check this first, we're going to end up returning 1 when in fact there's an obstacle, so we should have returned 0. Okay, so now that we have that, so now we just need to keep passing the obstacle grid back into the function. So we pass an obstacle grid here, and we pass an obstacle grid here. Now there's only, and then we also pass it in here. Now the thing is, in this problem, we don't, so we're just given the obstacle grid, so we don't have an n and an m. So basically, we can determine n and m by the size of the obstacle grid. So now um, instead of uh, m and m being provided, we're going to compute it. So let's see. So m, right, is the end x, and that means that it's equal to the number of columns, right? Because, and then um, n is the end y, so that means it's equal to the number of rows, because if the end y is, if the number of rows is 0, 1, 2, that means the end y coordinate would be 2, right? So um, so n would actually be the obstacle grid dot length. So that means if there are three rows or three arrays, that would be our m, I mean our n, and then our m would be the obstacle grid 0 dot length. Now I'm going to assume that the problem is not going to have empty arrays, but if it did, then we'd have to make sure we check for that null or empty arrays before we do this, because this could result in an exception. So yeah, that's about it. So we basically took our previous algorithm for unique paths and simply added in obstacles. So the only additional thing we did is to add, aside from passing around the parameters, we add this check here. If it's an obstacle, we return 0, and then we just have to compute m and n so that we can pass it into the same function that we had. So let's try running. Oops, extra there. Okay, compiled. Now let's try submitting it. Yep, it works. Alright, thank you for watching and have a good day.